On Earth's surface, the value of g is equal to 9.8 meter per second square. Meter per second square. What is this g, sir? What this g is? G is acceleration due to gravity. When an object is falling from a certain height, this g is equal to 9.8 meter per second square is exerted on it. This acceleration pulls it down towards the earth. So the g is nothing but it is 9.8 meter per second square on earth's surface. The value of g is equal to 9.8 meter per second square. That's great. So what the value of g last day we had derived? G is equal to gm by r square. G is equal to gm by r square. In terms of earth, you can refer it to re square, radius of earth square. Now we are taking an object to h height above the earth's surface. Above the earth's surface, we will take an object up to an h height. So what actually it means? What actually it means? When an object is taken to an h height above the earth's surface, when an object is taken up to h height about the earth's surface, then the effective range will be calculated as, that is the radius of earth re, radius of earth, and this the height of object. The object is taken up to h height. So this total distance will be re plus h. Re plus h will be the effective distance. Re plus h will be the effective distance. Now since we know g at earth's surface is equal to gm by r square, give it as first equation. At earth's surface g is equal to gm by r square, where g is the gravitational constant and capital M be the mass of earth. Mass of earth is capital M. The mass of small object is small m. Small m be the mass of an object which is taken to h height about the earth's surface. So give it as first equation. Mass of earth is nothing but it is 6 into 10 to the power 24 kilograms. Mass of earth is equal to 6 into 10 to the power 24 kilograms. 6 into 10 to the power 24 kilograms. Very huge value. On h height, the object is taken up to h height. On h height, the value of g is equal to gh on h height, since the object is taken at an h height. So gh is equal to gm by r plus h whole square. Now on comparing this expression in the first equation, on comparing equation first and second, we get taken a snapshot of it. When the height of an object is very greater than the radius of earth, when the height is much greater than that of the radius of earth, so case number first implies that when the height of the object is much greater than that of radius of earth, we will take gh is equal to gm by r plus h whole square. Gh is equal to gm by r plus h whole square. This will be the standard formula to calculate the value of acceleration due to gravity at an h height above the earth's surface. Earth surface. Again I am telling, we are taking an object up to h height above the Earth surface. So this will be the expression when h is much greater than that of the radius of Earth. This radius of Earth is nothing but it is 6400 kilometers or 6.4 into 10 to the power 6 meters. 6.4 into 10 to the power 6 meters. Again, case number first is clear. Case number first is clear. Case number first is clear. Case 2. Case number 2. When the height of the object up to h height the object is taken above the Earth's surface is very less than the radius of Earth. Okay. In case of an aeroplane, helicopter, we will take this expression on taking equation number first divided by second. On doing equation number first divided by second, we will get g by gh is equal to gm by r square into r plus h whole square by gm. So gm to gm will be cancelled out. So this expression will be finally, let me explain you. This expression will be finally g is equal to g by gh is equal to r plus h whole square by r square. R plus h whole square by r square. Let me erase this. On next step, we will take this power 2 power. 2 power is here, and again 2 power is in the numerator. So we will take 2 as the degree from numerator and denominator both. So g by gh is equal to r plus h by r the whole square. R plus h upon r whole square. On shifting this gh here, we will get g is equal to gh times r plus h upon r whole square. Now on the further step, next step, we will move on to, we will take the value in terms of gh. So gh will be is equal to g times r by r plus h by r to the power minus 2. Since we had taken this expression on this side and shifting gh on the above side, we are getting this value in terms of h. Why this reciprocal power? Because we had shifted two quantities. Okay, we had shifted numerator to denominator and denominator to numerator above side. Next, we are having on our next step gh is equal to g into brackets of 1 plus h by r to the whole power minus 2 since it is 1 r to r will be cancelled out. Now using binomial theorem, we can take this power in between. Since a plus b to the power minus n is very less than a plus b. Using this property, we can neglect the further values. Since 0.01 whole square is very less than 0.01. Using this property, square becomes shorter when in case of smaller digits, point digits. So using this property, we can arrive at the expression taking this minus 2 in between in the expression. We get we get GH is equal to G into brackets of 1 minus 2H by R. 1 minus 2H by R. This is the required expression. This is the required expression when the height of the object is much less than that of the radius of Earth. That of the radius of Earth. In this case, we will use this expression. We will use this expression. In case of aeroplanes and helicopter, this expression will be used. This expression will be used.